I'm Jennifer Murphy, and I'm a professor in the Department of Chemistry at the University of Toronto.
So welcome, Professor Murphy. It's very nice to have you in our I Am a Scientist series. To start off, we know that you're working in environmental chemistry and atmospheric chemistry. Can you introduce us a little bit about what those are?
Sure. So environmental chemistry is the study of how chemicals move within the environment. So in some cases, we think about natural systems. So how, how chemicals or elements that are part of biogeochemical cycles move through different compartments of the environment, like the atmosphere or water bodies or the soil. And in particular, we study what happens if contaminants, human-made chemicals, enter the environment, what their fate is going to be.
Thank you. So going deeper in that, what are some of the big discoveries in atmospheric chemistry so far?
I guess one that a lot of people are familiar with is in the 1970s, there was a recognition that some of the industrial chemicals that were being made were a threat, potential threat to the ozone layer. So about 15 kilometers above our head, there's a part of the atmosphere in the stratosphere that has a lot of ozone in it. And that ozone is very effective at blocking ultraviolet radiation from reaching the surface of the Earth. And so in the 70s, people started to understand that some of the chemicals that we generate at the surface and use in our products could make their way up to the stratosphere and threaten the ozone layer. And then in the 1980s, we started to notice that that was starting to happen, in particular over the South Pole. And so in the 1980s, the global community got together and agreed to start phasing out the use of those chemicals. So the phase out of chlorofluorocarbons to help protect the ozone layer is one really sort of well-known story of atmospheric chemistry. And then closer to home, the type of air pollution that a lot of people around the world experience in urban areas, which comes partly from chemicals that come straight out of tailpipes, but also from chemicals that are produced in the atmosphere, as a result of those emissions. In many parts of the world, we've been able to achieve improvements to air quality as a result of knowing which the bad offenders were in terms of the chemistry and regulating those accordingly.
Thank you for your answer. So you kind of touched on this, that our understanding of atmospheric chemistry has changed our way to approach different problems in the environment. So one of your research projects that we saw that recently was completed and awarded, it's the Netcare Project. So can you tell us a little bit more about this project and the impact of this project on our daily lives?
Yeah, Netcare was a really exciting opportunity for a large group of scientists around Canada and also with collaborators in the United States and across Europe to understand what factors influence the amount of aerosol that's in the atmosphere in remote environments. So aerosol are tiny particles that are either liquid or solid, and they're suspended in the air, and they impact the climate either by reflecting radiation directly or by influencing the amount of clouds that form and then cooling the planet like that. So not much is known in these very remote environments about what are the sources of these particles and what their fate is. And so we had the opportunity to travel to the Arctic and understand what the sources of particles are and how they influence the climate there. So that was a really exciting opportunity.
Yeah, just a follow-up question on your answer. So what do you think from this project, what we can do as, let's say, the public to help with our environment?
That's a good question. I mean, this is really part of the world. The part of the world that we were targeting with this study was a place that's pretty far from human influence. So one of our motivations for going there was a recognition that the Arctic is changing more quickly as a result of climate change than many other places, and that as sea ice retreats, there's the potential for a lot more ship traffic to be happening in the Arctic. And so what we know is that this is a really sensitive part of the Earth system. And so we should probably be thinking twice about whether it's a great idea to, just because you can start sailing ships through the Arctic, is that really the right thing to do? Because it could lead to even bigger feedbacks on climate. So I think it's one of our goals is to understand the natural system better and how sensitive it is to help people make good decisions about their actions.
Well, thank you very much for this answer. Looking in the future, what do you think is the future of the field of atmosphere chemistry? Like, for example, any technology that you're excited about, or any other research that you really intrigued to look into?
Those are great questions. There's lots of exciting areas of inquiry in atmospheric chemistry going forward. So I think understanding better these connections between climate change and the composition of the atmosphere is one really exciting area. So we know that things we emit into the atmosphere can cause the climate to change, but also the changing climate is going to feed back on, as sea ice retreats, there's more open ocean and there could be more emissions from phytoplankton, for example. So climate and chemistry connections is one exciting area. And then I think understanding the public health risks of being exposed to air pollution is also a really active area of research. And from a technology perspective, there are really exciting developments in terms of inexpensive, low-cost sensors that can be deployed in large networks. And so that will help us better determine the exposure of populations with a lot of spatial information. And it also opens the door to starting to interpret data. So there's sort of a data science aspect to that, because there's going to be volumes of data that we haven't really had to work with before.
Awesome. Thank you so much. And I know, like, recently there's the G20 conference, and I think, like, globally, we're really trying to push for a better environment and problem solving of these global warming issues. And I think really studying these atmospheric chemistry and science will really help us to accelerate our speed to help with global warming. Now, going back to your personal interest, so how did you first become interested in science?
I think when I was young, I was always very curious and I wanted to know how things worked. And so if you have the kind of brain that always wants to know why something is the way it is, then science is kind of a natural place to end up.
Yeah, I think curiosity is definitely a common trait with all the scientists we interview, and that drives your motivation to try to discover more. So during your career path, did you face any hardship?
I've been pretty fortunate. I've been able to study at some great places and have a lot of really supportive mentors. I think for women in science, there's always a few additional challenges because we aren't as prevalent and there aren't necessarily as many of us. And so especially with some of the field work I do and some of the more technical work, people aren't always expecting a woman to be doing it. But in general, I think I've had a pretty great experience being a scientist.
Awesome. And that's what our series really try to promote, women in science and minority in science. So last question, do you have any advice for kids who may be interested in STEM?
I think the most important thing is to stay curious and to be thinking about, doesn't really matter what you're interested in. It's more about cultivating an enthusiasm about not knowing the answer and thinking about ways you could test to see if something makes sense or not. And so I think, especially when you're young, the most important thing is to stay excited about it. So if you lose interest in one thing, you can start to consider something else, and really maintaining that curiosity and love of learning is really the key.
Yeah, great answer. Thank you so much, Professor Murphy, again for this interview.